Ayan. So, hello everyone. Today we'll be doing 5 problems in the module of fluid mechanics. So, if you're watching this, I probably sent you this video, and I hope you have your module here with you so you can solve along with me while we do these problems. And nga, if you're wondering, I've been gone from making videos for almost 4 to 5 months na then, primarily because nga, I've been in a slump the past semester. But still, even all through those hardships, I survived naman. And again, this is a new semester, a new beginning. So may chance pa rin to turn things around, ano? And before we start, quick shout out lang to my new block for the semester, ME2202. Uh, so far, I'm enjoying the vibes naman, and I think uh, it's going to be a good experience until the end of the semester, ano? And without further ado, let's begin solving these problems. By the way, disclaimer, I'm not an expert uh, through these things. I'm just also a curious student myself then. Ano? So these problems are on the first part of the module, right after the first discussion. I think there were 13 problems, and I only did 5. So maybe you can do the rest on your own as well. Okay, so for the first problem, we're asked, what is the bulk modulus of a body that experienced a change of pressure 5 times 10 to the fourth power Newton per square meter, and its volume goes from 4 cubic centimeters to 3.9 cubic centimeters? And so for this problem, always start with the given. Ano? Let's write the given. Okay. And so we have a change in pressure, delta P, 5 times 10 to the fourth Newton per square meter is the same as pascals. And we have a change in volume. So we have a V1 that is 4 cubic centimeters. And V2 is 3.9 cubic centimeters. Ano? So we're asked to find the bulk modulus, P. In some other textbooks, I recall yung bulk modulus is denoted as K. And I think yun din natin yung ginamit ng physics 1, if I still recall. And let's solve for this. So ayan, the formula for the bulk modulus, since yung unang part din naman ng fluid mechanics is a rough review of what we learned in physics. So the formula would be delta P, the change in pressure, over the delta V over V. This V is the original volume, so that would be V1. No? And ang unit ng bulk modulus is still in terms of pressure, so pascals. Ano? So, yun nga. At this point, it's just a direct sub of what we have here. So it's 5 times 10 to the fourth power pascals over and force cm cube minus 3.9 cm cube. Or I could have just distributed the cm cube, but that's fine. Over the original volume, 4 cm cube. Ano? And then this will all just cancel. If you want, you can convert it to uh, cubic meters if you want, but that's just extra work. And makakancel din naman yung units and you arrive at the same answer. Ano? It's still in pascals. So if you input that in your calculator, check lang natin. So you'll end up with 2 million or 2 times 10 to the sixth power pascals. And if you want to make that simpler, you can just do some unit analysis and convert it to megapascals. That would be 2 megapascals. Since there is 1 million pascals in a megapascal. Okay. And since this is the simpler answer, this will be our final answer. Ano? So yan. So basically the bulk modulus of this body is 2 megapascals. And I think it's relatively a low value compared to like water. May mga thousands of megapascals of their bulk modulus. So I think the material here would be something like soft gels or probably soft tissues of humans or probably something like that. Ano. So yun, yeah, it helps to know uh, some trivia in solving problems so you can have a broad idea of what you're trying to solve. And yeah, that's it for problem number 1. Let's move on to problem 2. Okay, so we have to calculate the dynamic viscosity of an oil which is used for lubrication between a square plate of size 0.8 meters times 0.8 meters or zero point 0.8 by zero point 0.8 meters and an inclined plane with angle of inclination 30 degrees as shown in the figure. The weight of the square plate is 300 newtons and it slides down the inclined plane with a uniform velocity of 0.3 meters per second. The thickness of the oil film is 1.5 millimeters. Ano? So for this part, yeah, we have a figure already that I've kind of drawn here. Okay, let's start with the given. Let's do it here. Okay, so first, we have the angle theta, that is 30 degrees. You have the weight, 200 newtons. Will that be the force? We have a thickness, 1.5 millimeters. Plus we have velocity, and I guess we have an area. Okay. Like that. Okay. We're asked to find the dynamic viscosity. The dynamic viscosity is denoted by mu, the Greek letter. And then yeah, uh, huh, can calculate for this. Actually, this is not part of what is in the module, the formula, since yung nasa formula sa module is for, I think that's the shear stress, denoted by tau, like this weird looking T, that is equal to the dynamic viscosity times the velocity gradient, du over dy, like that. Ano? And velocity gradient is, I think, it is the change in velocity with respect to the distance. So you're expecting like meters per second over meter. So I think that would be something resembling a unit of inverse seconds. Ano? Okay. Anyways, since the shear stress is still a unit of pressure, so that's force over area, we can calculate that. Since we have the force, we have an angle, and we also have the area. So we can calculate that. So if you want to shift solve this, then by all means, okay lang. But if you want to know the derivation of this formula para din mas clear yung units natin, I think that would be optimal. Ano? Mm, so what we do is we just multiply the reciprocal of this. So it's dy over du on both sides. Okay, so this will cancel each other out, and you're left with this dynamic viscosity. Okay, so now our formula will be the shear stress tau times dy over du. Would that be right? Yes. Okay, now let's plug in the values. So for this one, we have the pressure. So that's 300 newtons times the angle, 30 degrees. And since it's going up, it's going to be a sine function. So that's sine theta, sine of 30 degrees. Okay? Yeah. And for this one, we have to consider the thickness. We will use the thickness as, I think, would that be the height in this case? Yeah, since it's this one. So, yeah, actually, this is over there. Yeah, yeah. This is over 0.8 times 0.8 is 0.64 square meters. Yeah, so this will be in pascals. And we just multiply this to the reciprocal of the velocity gradient. So now, instead of the unit of distance being on the bottom, it's now on top. So it's 1.5 millimeters. And to convert that to meters, i-ano mo lang, i-multiply mo, or you will divide it by 1,000. So that's 10 raised to 3, negative 3 meters over. This is 0.3 meters per second. And now this will be reciprocated and this will be cancelled. Okay, so let's try to calculate that. 100 sine 30. And then we have 1.5 sine 3. Yeah, so we'll have 1.171. That is 87, so let's just round it off to 9. And the unit is this is pascals, and we have a second there, so that would be Pascal second. Okay, that's the unit for the dynamic viscosity, Pascal second. And if you want to convert it into other units such as poise or centipoise, for poise you just multiply it by 10, and for centipoise you multiply it by 1,000. But let's keep this as it is. No, this is our answer for this one. The dynamic viscosity would be 1.1719 approximately Pascal second. So I hope it's clear around the derivation of the formula. Again, kung gusto nyo i-shift solve, yeah, that works if you want to shift solve. But this is just to make sure that yung unit analysis is much more clear. So it's up to you guys. Diskarte pa lang. Okay. For the third problem, Like this one, yeah, took me a whole page to try to do it. Okay, that's because I was using multiple approaches. Okay, so for the third problem, graduated cylinder is filled to the 40 milliliter mark with mineral oil. The masses of the cylinder before and after the addition of mineral oil are 124.966 grams and 159.446 grams. In a separate experiment, a metal ball bearing of mass 18.713 grams is placed in the cylinder and the cylinder is again filled to the 40 milliliter mark with the mineral oil. The combined mass of the ball bearing and mineral oil is 50.152 grams. Calculate the density of the ball bearing. So, sounds like a lot to take in, but it's much more simpler than it looks. At first glance, uh, you may think na, ay, pwede dito yung principle of buoyancy ni Archimedes. However, hindi tayo nabigyan ng initial buoyant force. Although you may think na, let's do it here. The formula is for the buoyant force, it would be the density of the fluid times the gravity times the volume displaced. However, we're actually missing the buoyant force here. Even though, tingnan natin. Let's say we have a cylinder here, like that. Say that has an initial value, ano, and then you add the ball to it, like here. When you add the ball, let's say it fell down here, it will rise. So it displaces volume. Yeah, that's the concept. However, we're missing this crucial part. So dito, even though mukhang promising na gamitan yung buoyancy, it's actually just the properties of fluids. Parang yun lang yung gagamitin mo. However, meron pa ring displacement ng volume. Ano? Okay, so let's write the given. Mm, let's separate it into for the experiment. So we have the experiment one. So we have mass one. That'd be 124.966 grams. Mass 2, 159.446 grams. Yeah. And for experiment 2, you have the mass of the ball, 18.713. Actually, you have a volume here, right? And we have a total mass. Yeah, mass total is 50.952 grams. We're asked to find the density of the ball bearing. And I think this volume is constant here, ano? Tapos dito yung final volume lang yung 40 milliliters. Yeah. So, basically, when we're doing the approach na yung fluid properties lang, we have to take the data from this and apply to this. Parang yun yung concept niya. So, first, we have to calculate the mass of the oil using these here. Ano? That would be M2 minus M1. It's higher minus lower, of course. And when you input that in your calculator, 966, right? You will have, let's just write it here first. 34.966. This is in grams. So you will have 34.48 grams. Ano? And now that you have the mass and the volume, you can calculate for the density. Okay, and since this is, I believe, constant for this one, we leave it as it is and solve for it. So the density of the oil will be equal to the mass, 34.48 grams over 40 milliliters. Okay, yeah. And that would be equal to 0.862 grams per milliliter per ml. Okay, para di tayo mahirapan, let's just store it. Let's store it to A. Now that we have the density of the mineral oil, we can move on to experiment 2, where there is the metal ball bearing involved. Ano? So for this is not experiment 1. Actually forgot to write the solution. And let's just put the asked here. This is the density of the ball bearing. Okay. For experiment 2, first we need to find the mass of the oil. Ano? Mass of the oil. Again, we can do that by subtracting the mass of the ball bearing to the total mass. So that's 50.952 minus 18.713. This is in grams. So we have 32.239 grams. Ano? And again, since we have the density and we have the mass, we can compute for the volume. So volume is the mass over the density. Okay, so the mass is 32.239 grams, and we store the value of 0.862, so that's AML. Okay, and now we have around 37.40023, so on. That is milliliters. And let's store that. Store that to B. Ano? And now that we have the volume of mineral oil, yeah, we can compute for the density of the ball bearing. Since if you subtracted this into the 40 milliliters, you will have the volume of the ball bearing. Ano? Yeah, so that's pretty nice. So we have 18.713 grams, and we have 40 minus the value is stored in B. This is in milliliters. Okay. 18.713 over 40 minus B. So our answer would be 7.197. That's 5, so that's 8. Yeah, 1978. Yeah, yeah, that's right. Grams per milliliter. I was confused. Okay, so this is our final answer here. So ayan, yung density ng metal ball bearing is approximate na to, 7.198 grams per milliliter. Well, if you have other answers, please do let me know. Maybe I made a mistake somewhere. Ano? But I guess this would be the answer. It's logical naman yung process din natin. Okay. Let's move on to the next problem. So for this one, rolls of aluminum foil are 206 millimeter wide and 0.0140 millimeter thick. What maximum length of aluminum foil can be made from 0.834 kilograms of aluminum? The density of aluminum is 2.70 grams per cubic centimeter. And for this one, it might look hard at first since maximum length, but let me show you how you can deal with these types of problems. So generally the volume formula is length times width times height. So we'll be using that idea here. Ano? But it really doesn't matter what you lack since length naman yung hinahanap. We're already given two components here and makakompute naman natin yan. So instead of writing that, let's just illustrate it. Say like this. Say parang may ano dyan. Let's say it's the aluminum foil. Yung roll. Okay. It's not the best drawing, but it gets the job done. So its mass is 0.834 kilograms. Ano? The density 2.70 grams per cubic centimeter. And yeah, let's try to illustrate. So yung parang lapad niya, okay, like this. I don't know if I'm doing it right. So this would be 206 millimeters. And then let's say ano siya kakapal. Or maybe it's the other way around. It doesn't really matter. 0.0140 millimeters. Okay? And we're asked to find the maximum length. So it's L max. No. And the idea here is what I've said earlier. It's the volume over the area that will give us the length. Since if you think about it, ang unit na to is typically meter cube over meter squared. So this will cancel. You have one left here as the power, and this would be the unit of the length. Ano? So that's the idea. And we can compute the volume since we have the mass and we have the density. So it's much simpler now. So let's just write a solution here. I think it would fit. Yeah, actually, yeah, I think it would fit. So first, calculate muna natin yung volume. That's mass over density. And since mas madaling ilipat na lang tong 0.834 kilograms to grams instead of this turning it into kilograms per cubic meter. So madali ito. So I just multiply the value by 1000. So this is 834 grams over 2.70. This will cancel. And when you do this in your calculator, you will have 308.8888 and so on. Let's store this. This is cubic centimeter, by the way. We'll store this to A. Okay? Shift store to A. Now, it's just a matter of, ano, yeah, it's just a matter of converting this millimeters to centimeters. Ano. And we know that 1 centimeter is equal to 10 millimeters. You know by your rulers. Right? You find that commonly there. Okay. So let's compute for the area. The area is this. Let's just divide this by 10. Yeah. Times 0.014 times 10. This will be in cm now. Okay. Let's do this. 0.014 10. Yeah. So we will have 0.04284 square centimeters. Let's store this into B. Ano? Okay. So we have A and B. Finally, to again volume over area will give us the length. Therefore, you have the volume stored in A times the area stored in B. Cancel, cancel. This will be left with 1. And let's do that real quick. You have this 7,210.291524. This is in centimeters. And if you want to convert it into meters, yeah, I guess you'll just divide this by what? 100. Yeah, since 1 meter has 100 cm. This will cancel, and you have 72.1029. Yeah, meters. So this is the maximum length. Yeah. Ayan. So the maximum length of the aluminum foil is 72.1029 meters. That's quite long. Ano? And yeah, this is for problem number 4. And for the fifth problem, this is just what we have in thermodynamics. This is just a raw GH. Ano? So there's a water tank with a height of 9 meters filled with water. Using the water pressure formula, you need to calculate its pressure at the bottom. So ayan. So we're at the given, as usual. We have a height, 9 meters. And we know that the density of water is 1000 kilograms per cubic meter. And G is 9.81 meters per second squared. Ano? We're asked to find the pressure at the bottom. Writing our solution, we know that pressure is equal to raw GH. And this, we just substitute. Is 1000 kilograms per cubic meter times 9.81 meters per second squared. Yeah. And the height, 9 meters. No. And I guess what would cancel here is we'll just cancel each other out. Here's meters. We've cancelled this. Yeah. That. Yeah. Since that will give you pascals, newtons per square meter. So when you input that in your calculator, you should have an answer of 88,290 pascals. Or that would be 88.290 kilopascals. We'll try to make it simpler. Just divide it by 1000. And that's it. So those were the 5 problems. I guess the previous problems were a bit more tricky than the last ones. But still, it served as parang refresher na din as to what we've learned in physics before. Kasi yun nga, in physics, we've dealt with these before. Medyo advanced lang dito sa mga water pressure na to, but we already tackled it on Thermo 1. So ayan, there are more problems in the module. Probably I might solve them. And so should you guys, ano, para medyo ano pa rin tayo, we're prepared, I guess. And I know naman, if you have learned something, I that's really the best I can offer, ano. Well, I'm also learning this as well. So, ayun nga, thank you guys for staying till the end if you're here. And and thank you guys. And actually, I want to do this quote. uh, the outro by Ma'am Alin. Yeah, the happy learning one. Happy learning. Okay, bye.